absolutely, Henrik. Questions that I've been asking all my life, and I was very dissatisfied with how orthodox science is addressing these questions. We seem to be getting nowhere over the past 80 years, since Rutherford worked on the atom and since James Chadwick worked on the atom in the 1930s. And I began to consider, like many others have before me, that the orthodox science must be looking at things in the wrong way. So I decided to answer the questions in orthodox physics rather than trying to answer the big one of gravity. I started to address all of the other smaller questions, which were just as important. For example, why doesn't the atom spring apart, given that it's filled with positive charges in the nucleus? Why don't the nuclei of atoms just spring apart? Another one of the basic fundamental questions of physics is why don't the orbiting negative electrons get sucked into the positive nucleus? Nobody seems to know. And yet we're trying to figure out how gravity works when we can't understand how the atom works. Is it any surprise that we're not making any progress? Another of the fundamental questions is why are the orbital shells of atoms offset as they are? Nobody knows. How does gravity work? We'll address that shortly. How does permanent magnetism work? They don't know. If you ask a physicist how permanent magnets work, they say it must be magic. That's why they called it a magnet. How does electricity work? At atomic level, nobody knows. Nobody knows why, when an electric current flows through a wire, a magnetic field is established around the wire. And we can look at the field of astrophysics. Why do stars cluster as they do? Orthodox physics talks about dark matter, but it doesn't make sense. Why are the galaxies spiral-shaped? Again, nobody knows. It shouldn't be that way. What drives the sunspot cycle? Again, nobody knows what causes a sunspot cycle. What causes global warming and global cooling? Now, if we are to figure out the fundamentals like gravity and electricity and magnetism, we have to start with the atom and the fundamentals of magnetism and electricity. And that's what I've done in the book. I started at the beginning. I went back to where we were on firm ground with Rutherford and Chadwick in the 1930s. I looked at the atom. I looked at the changes they made in our understanding of the atom. And from there, it was all downhill. And it was very simple to figure out how gravity worked once I'd figured out what made the atom stable, for example. And it took me 6 weeks to figure out how gravity worked. That was in 2007. And it's taken me 3 years to find a way of explaining it. It's simple, it's complex at the same time, and yet without the graphics and the illustrations, I think it's like having a game of chess, thinking 12 steps ahead. And it's very difficult to explain unless you can illustrate it. And the new book, Future Science, has got more than 140 illustrations, most of them full page in color. And it's for the general reader with no previous knowledge of science. And it explains, if you like, a grand unified field theory. It explains how electricity and magnetism work together to produce a force of gravity, which allows us to understand why objects fall to the ground when we drop them. I mean, it's hard to believe in this so-called modern age of 2011 that modern man cannot explain why objects fall to the ground when we drop them. I mean, it's quite bizarre. We are, in fact, very primitive beings. And once we get our head around the fact that we're primitive, that's when we start to make progress.
Absolutely. I mean, you're an engineer and a scientist, Maurice, but in one way, as far as I know, you're not associated with any university per se. You don't, you know, come from, you're not in the world of academia. You're kind of standing on the outside of that, of course, as well. But at the same time, a lot of the people who came with new ideas were from that world as well. People who never finished school, the people who are you know, fundamentally capable of thinking outside of the box, so to speak. This seems to be a kind of a necessity, if you will, when you want to try to answer some of these very difficult questions, Maurice.
It's absolutely essential. If, for example, to use an analogy, you're driving in a car and the car swerves off the road and finishes up in a ditch, it's no good trying to push the car out of the ditch. You have to pull it out backwards and figure out how it got into the ditch in the first place. Now, my view is, if you give a physicist a shovel, he'll dig a hole. And they've been digging a hole for 80 years. And now they can only communicate with each other inside the hole. They can't communicate with people outside the hole. Their ideas are fixed. They can't see anything because they're in the dark, and it takes somebody from the outside, from the periphery, with a completely fresh mind, who has nothing to lose by arguing with them. You see, these people, they can't argue with themselves because they get thrown out of the institutes and things like that. I'm not a member of the Institute of Physics, so they can't hurt me. They can't throw me out. I'm an engineer. I'm a member of the UK Institute of Engineering and Technology. It's not within their remit to look at gravity or the fundamentals of electricity. They acknowledge that that falls within the Institute of Physics. So it's got to come from somebody on the outside who's got nothing to fear from being thrown out, if you like, or attacked by these people, and who can see things with a fresh eye. One of the problems has been, when I started to look at this, was I had to learn as I was going along, because the answer lies both in engineering, it lies in chemistry, and it lies in physics. And one of the problems of modern science is that these disciplines are very separated and individual. The physicist doesn't know what the engineer is doing, the engineer doesn't know what the chemist is doing, the chemist doesn't know what the other two are doing, and it's very difficult for a specific researcher who's bogged down in his own discipline to appreciate how all of the disciplines relate to each other.
Yeah.
And being an independent researcher, I've taught myself from looking at ancient civilizations in the beginning many years ago, and to looking at spiritual inquiries as to, for example, what God is and what heaven is and what hell is, and the sunspot cycle and things like that, which I found fascinating. And I had to bring all of these things together to get a complete picture of life, the universe, why we're here, why we live, why we die, why this has to be. And once that was all my groundwork. I did my apprenticeship, if you like, in things like that. So when I got, I actually sat down one day and I said to my wife, it was winter in Ireland where I live, the dark nights had come along, and it was Christmas, just after Christmas time, 2007, and I said, I think the next project will be gravity. And I sat down on January the 1st and I started to look at gravity. And 42 days later, it was on Valentine's Day, I realized how gravity had to work. And just a few days after that, I went down to one of the UFO conferences in Nevada and gave a lecture, and it was called How Gravity Works. It was a bit presumptuous because I was saying this is how it had to work. And I came back home from the conference and I realized perhaps I should have called it How Gravity Must Work rather than How It Did Work. And for the 3 years that followed, I had to figure out a step-by-step mechanism to explain how gravity worked, then reconcile it with Newton's equation, and then put it in a format which would bring and embrace all of the fundamental questions that we mentioned earlier about the atom and magnetism, electricity, and so on. And once I did that, of course, it was all downhill. It was easy. But I was fortunate in a way in that I had nobody looking over my shoulder. I was able to work at my own speed and also learn from the ancients, because the ancient sun-worshipping civilizations like the Mayas, the Egyptians, the Celtic people of Europe, the ancient Chinese, the Incas, before the Incas, the Mochica in Peru, and the Tiahuanacos from Tiahuanaco in Bolivia, all of these people were very advanced in their civilization and their technology. And it's only now that modern science is beginning to appreciate just how far ahead they were of us today. And once you get your head around that, you can feel very humble, if you like, and stand back from the inquiry and appreciate or take a holistic approach at what we're doing here and realize that gravity, or figuring out how gravity works, cannot have anything to do with intelligence, because people more intelligent than me have addressed the question and have failed to find an answer. Therefore, it's got nothing to do with intelligence. So we have to look at the problem in a different way. We have to look at it completely differently. For example, being spiritually predisposed, I recognized many years ago that a swallow, for example, a small bird flying through a tree at 100 miles an hour through the branches of a tree, owed nothing to intelligence because the bird has a brain the size of a pea. So there must be something else in the bird which allows the dexterity and the speed and the skill, which allows that bird to fly through that tree at 100 miles an hour without damaging itself.
Right.
And of course, it's the God inside the bird that flies. It's not the bird. And it's the God inside human beings that allows us to think things through, reason things out. One of those tricks I found many years ago was if I couldn't figure something out, I'd sleep on it, and in the morning or in the early hours of the morning, I'd wake up in the morning, and the answer would be in my brain. And this is not because my brain figured it out. It's because the God inside my brain figured it out. And that's what's so fascinating. And once you realize that knowledge is there for everybody, and wisdom is there for everybody, God doesn't expect us to be brilliant or clever to access his universe. All we need to do is love God and love the universe. And it's then that we start to find answers to everything. And once we make one discovery, it leads on to another discovery. And that leads on to another discovery. And that's good science. Bad science, cul-de-sac science, is when we finish up in a dead end and they start performing experiments which are irrelevant, which are flawed, and they start giving answers to themselves to support their own misconceptions. Right. And they dig their hole deeper and deeper and deeper. And, of course, they become disassociated with society completely, living in a world of their own where it pays them not to make a discovery. For example, physicists today earn billions of dollars every year, or I shouldn't say earn, they access billions of dollars of taxpayers' money to look for the cause of gravity. So there's no incentive for them to find the cause of gravity, because if they found it, they'd all be out of work the next day.
That's a good point. That's a really good point.
They don't want it. And the same goes for even in the medical profession, cancer. Billions of dollars a year are put into finding cures for cancer. Right. Now, of course, the last thing they want to do is to find a cure for cancer, because, again, they'd all be out of business.
Absolutely. So, it's a good point, Maurice. And I mean, we're given a lot of strange, unproven aspects in physics and space, and other fields as well that we hear about. Everything from gluons and Higgs boson particles to tachyons, superstrings, and dark matter. And we seem to get more and more into the mysterious aspects of us when we should be coming closer to an answer, just as you allude to. But I mean, where do we need to look then, if you know what I mean, Maurice, in order to solve some of these mysteries? If we look at, for instance, some of the things that you go into, what drives the sunspot cycle, why are the galaxies spiral shaped, and of course how gravity works, do we need to look into the molecular level, the atomic level to begin to find some of these answers then, Maurice?
Absolutely. We need to start at the beginning, go through the middle, and finish up at the end. That's what we need to do. Now, what has happened with science, or orthodox science, is whenever it gets a difficult problem, it pushes it to one side, kicks the can down the road, and moves on to something more interesting, like genetics or whatever. Now, you can't do that. You've got to start at the beginning and take small steps at a time. I mean, you were talking about gluons. I mean, it goes back to about 1935. It all began in particle physics about that time, where a researcher called Yukawa questioned, why do all the protons stick together in the middle of atoms? Given that positive repels positive, why don't they just spring apart? So he suggested, well, they must be sort of glued together. Maybe when the universe was created and we had a big bang, that all of these positive charges were sort of covered in a glue, and the glue is stronger than the actual positive charge, which is pushing them apart. So that's why they stay glued together. But shortly after that, another researcher objected to that. And he said, well, look, okay, let's say you've got two types of Velcro, a sort of velvet side and a hook side, holding these protons together. Let's say some of the protons are covered in positive or velvet side Velcro, and some of the protons are covered in hook side or negative sort of Velcro. The problem is you must get some atoms where all the positive Velcro, the velvet side, are bunched up together, and you must find other atoms where all the hook side of the velvets are all bound together, so they would still spring apart. So another guy came along, he said, that's true, so you'd need 3 times of Velcro, 3 types. But then another guy came along and he said, well, actually, that wouldn't work. You'd actually need 3 types of each of the 3 types. You'd actually need 9 types. And another guy came along, and he said, well, that's no good either. Now, what happened is particle physics went crazy about that time, about 1935 to 40. And they're now looking for 300 different particles. And the Oxford Science Dictionary says this about it. It says the whole elaborate theory is circumstantial. None of the smaller particles have ever been identified in experiments. The theory does not claim to have been verified. What I found is none of the particles exist. None of these particles, these gluons exist. You don't need them. Once you start at the beginning, figure out how the atom's made and constructed, then we realize what makes the atom stable. Once we know what makes the atom stable, we can understand how the atom is affected by electromagnetic radiation or energy. And once we get the energy and the matter interacting, that's when we can understand how gravity works. And unless you do it that way, you're not going to find the answers. It's no good jumping from black holes to quasars to gluons. Every time they get a problem, they shove it to one side and marginalize it and move on, and then dust themselves down, give them a few awards and Nobel Prizes, and move on to something else they don't know anything about.
That's right. What do you make of CERN then, the particle accelerator, the world's most expensive science experiments, when the Europeans, many of the European countries, their economy is totally going down the drain. We're spending billions of euros on this particle accelerator, a big spin cycle. Is it all a waste to look for this Higgs boson particle or God particle, Maurice?
A complete waste of time. Absolute waste of money, waste of time, waste of space. There are two particles, electrons and protons. The neutron, we know from the 1960s, experiments of the 1960s, is made up of a half of an electron glued to half of a proton. And in fact, it's not even glued. They're fused together like a junction diode. And what happens is when you fuse a junction diode together in electronics, you put two materials together, a negative type material, which we call N-type, and a positive type material, which we call P-type. And we fuse them together. And when you fuse them, in between the two, you get a junction, which is on the one side positive and on the other side negative. Now, the junction only exists because we fuse them together. And the same thing happens with a neutron. A neutron, when we fuse together a half of one electron with a half of a proton, we get a boundary between the two, which particle physics have called an antineutrino. Now, what we know about the antineutrino is if we smash them apart, as they did in the particle accelerators in the 1960s, they smashed two neutrons together like boiled eggs, and they finished up with two negative particles, two positive particles, and two neutral particles, which they called the antineutrino. Now, I'm saying the antineutrino doesn't exist. It's a corridor of fusion. What they find is that the antineutrino completely disappears 12 minutes after the experiment. So if you smash two neutrons together, you finish up with two negatives, two positives, two neutral charges, which disappears completely. It just vaporizes after 12 minutes. Well, if it disappears, it never existed. And the reason it never existed is because it's not a particle, it's a corridor of fusion. So that allows us to simplify things. If we've only got an electron and a proton, and a neutron is actually a combination of one half of each, then we can put the atom back together slightly differently to how Rutherford did it in the 1920s. Now, Rutherford described the atom as billiard ball style protons, negative like the negative sign in notation. He looked at his electrons as little negative signs. And the protons, once Chadwick discovered them in 1935, he put them as another billiard ball inside the nucleus of a different color. Now, that's why they couldn't figure out how gravity worked. What I've done is I said, look, these neutrons aren't spheres. They're not circular. They're actually spike-shaped. You've got an electron at one end, half of an electron at one end, half of a proton at the other end, fused together with this so-called corridor of antineutrino in the middle, and it's a spike-shaped. And this isn't fanciful thinking. Science Daily, the web-based science magazine, reported in 2008, about March, as recently as that, 3 years ago, that researchers at the Hahn-Meitner Institute in Berlin have discovered that neutrons behave like compass needles. And what that means is that they align themselves like in line with magnetic fields. So that what they're saying is they've discovered in 2008 that they're spike-shaped. Now, in 2007, when I came up with my theory on gravity, I said the neutron must be spike-shaped because this is what makes the atom stable. So the atom, in my model, looks like a chestnut shell with spikes. So it's spherical, and it's got spikes. Now, the bit in the middle, the protons, are the round bit. Then we've got the spikes, which are the neutrons sticking out of the shell, and they've got negative tips on the edges of each spike. And the electrons can't get to the nucleus because they're repelled by the negative spikes on each of the neutrons. And that's what makes the atom stable. The neutrons behave like springs. They force the protons together and they force the electrons out, and the electrons push on the spiked neutrons, keeping the whole atom stable. And that's why the atom's stable. And once we've stabilized the atom, now we can have a look at what we would need to get energy to interact with that atom, the shape of that atom, to allow us to come up with a mechanism to explain gravity. And that's what future science does. At the beginning, I mean, there's a lot in the book. It's only the first 100 pages or so that's involved with gravity and sunspot cycles and astrology and magnetism, electricity and stuff like that.
Absolutely. I mean, and again, as you mentioned, Maurice, the book is beautifully illustrated, and it's a necessity to obviously to completely understand your work, of course, to get a bigger idea, a better idea of what we're talking about here. But some of the things I'd like to go into a little more in detail, obviously, is, I mean, explanation for how gravity works. That's amazing. It's really, really interesting hearing about this, and also how I've always been interested in your work specifically on the sun, the science of the sun, of course, and one of the big mysteries is the solar flares, the sunspot cycle. What drives this? What is the force behind this, Maurice?
Well, of course I know what it is, but orthodox science doesn't understand what it is. What orthodox science recognizes is that the sun is made of plasma, which is like a superheated sticky gas. And it recognizes that the sun spins on its axis. Just like the Earth spins every 24 hours, the sun spins every 37 days on its axis. But the equatorial region of the sun actually spins more quickly. If you were to look at one part of the sun, on the surface of the sun, then although the North Pole takes 37 days to go round once, and the South Pole does the same, the bit around the middle only takes 26 days to spin once. In other words, the middle of the sun, the equator of the sun, moves a lot more quickly than the higher latitudes. Now, they don't know what causes this, but they refer to it as the differential rotation of the sun's latitudes. Now, in 1970 or thereabouts, two engineers, Babcock and Layton, put forward a theory for a mechanism for sunspots. And they said that because the equator goes round more quickly than in the north-south magnetic field, which goes from the north pole of the sun to the south pole of the sun, just like the Earth's magnetic field, the sun's got one the same, then because the middle's going around more quickly, the magnetic field gets bent. Then it gets a little bit more bent. And after about 11 years, the vertical field actually finishes up horizontally across the sun. It's like wrapping spaghetti around the sun or an elastic band. If you imagine an elastic band going from north to south, and then you hook your finger in that elastic band as it spins, then you can see the elastic band becomes horizontal instead of vertical. And that's what they proposed. Now, what I've said is, well, what causes the equator of the sun to move around more quickly than the northern and southern latitudes? Now, the ancient civilizations like the Maya were aware of this rotation of the sun 1,250 years ago in the jungles of Mexico. They were also aware of the sunspot cycle and the effects of the sun on the Earth. For example, as I just mentioned, the equator of the sun takes only 26 days to go around once on the sun's surface. If you're an observer watching from Earth, because the Earth is moving, then you would see the same point on the sun come back every 28 days, not 26. And this is why the ancient Maya and the Egyptians worshipped the sun as the god of fertility because they understood that the sun showers off particles, that those particles impinge upon the Van Allen belts, the radiation belts around the Earth that protect us from harmful rays from the sun. The magnetic field of the Earth changes as a consequence of that bombardment of solar energy into the Van Allen belts. The magnetic field of the Earth changes, the pineal gland inside females changes, and the production of estrogen and progesterone, the fertility hormones, changes every 28 days as the sun spins. This is why females menstruate every 28 days. This is what causes fertility on Earth. And the longer cycles of the sun, which I calculated in 1989 as 187 years, the 187-year cycle mixes with the fundamental sunspot cycle, which happens to be 11.4929 years long. And together they produce a cycle 18,139 years long. And that cycle shifts direction 5 times during the 18,000 years. The magnetic field of the sun switches from northeast to southeast 5 times during that 18,000-year period. And the ancient civilizations were aware of this knowledge, and they knew that when the Mayan calendar began in 3113 BC, at that time the sun's magnetic field shifted from northeast to southeast. What happened then was the planet Venus twisted on its axis and turned upside down. And that's why Venus takes 224 days now. For one day on Venus is so slow, it's slowed right down. And Venus spins upside down because it was tilted upside down by the magnetic twist in 3113 BC. Now, the Earth didn't twist on that occasion, but it can do. It didn't twist because it was too far away and the magnetic twisting moments were not strong enough on that occasion. But we're pretty certain that the Earth has shifted on its axis in the past many times. And this has accounted for all kinds of phenomenon that Immanuel Velikovsky describes very well in his books,
right,
about pole shifts and so on. Now, what happens with the sunspot cycle as far as the Mayas are concerned is their calendar began in 3113 BC. And they calculated, as I did in 1989, that another magnetic reversal would happen 1,366,040 days after the Mayan calendar began. Now, we have to remember that when the Mayan calendar began, there were no Mayans. The Mayans didn't appear for 3,000 years later.
Mm-hmm.
So it raises the question, why did this civilization who appeared around 0 AD, why did they pick a calendar that began 3,113 years earlier? And for them it was important because they had calculated that 1,366,040 days after that magnetic shift, another magnetic shift would happen, and it would affect them in the year 700 AD. And that's what happened in 700 AD to about 750. The magnetic field of the Earth, of the sun shifted again. That had several effects. When we get a magnetic shift like that, a change in the sunspot cycle, we get mini ice ages on Earth. That causes lower temperatures. That causes less rainfall because less water evaporates from the oceans, and that leads to drought, especially important in equatorial regions. So they had no food to eat, they had no water to drink, and worse than that, no babies were being born because the sun's radiation, the fertility levels were changed because the sun's magnetic field changed. So not only did we have no babies being born around the equatorial region, but we had more X-rays coming from the sun because it was a sunspot minimum. So we get more X-rays coming from the sun. Those X-rays strike the equatorial region of the sun more perpendicularly than they do in northern and southern latitudes on the Earth. And that means that early impregnated ovum in pregnant females at the time would be bombarded by X-rays, and we all know that X-rays cause spontaneous fetal abortion.
Right.
So the Maya were hit by 3 whammies. They had no food to eat, no water to drink. They had no fertility because there were no fertility hormones. And the X-rays from the sun were causing spontaneous fetal abortions to all the women who did get pregnant. So it's just no surprise that the Mayas died out in around 750 AD, all because of the sun. And what I've discovered in my previous books, which is all set down in Future Science, if we look at the rotation rates of the actual sun itself, and what we find is, if we assume that the entire region of the sun spins at 9.729 degrees a day, that means it's got a 37-day rotational rate. Then what we have to do is have a look at the rotation rate of Mercury, which spins on its axis 87.96 days. What that means is that Mercury moves 4.09 degrees per day around the equator of the sun. And what I've discovered is that that movement speeds up the equator to 26 days on the surface of the sun, 28 days from Earth. So it's the planet Mercury, the magnetic field of the planet Mercury, orbiting the sun, closely to the sun, which drags the plasma of the sun around faster at the equator than it does at the poles. That results in the vertical magnetic field becoming horizontal. That causes sunspots, brown spots on the surface of the sun, approximately every 11 years, but also in longer cycles of 187 years and longer magnetic cycles of 18,000, as I mentioned earlier, which change 5 times during that period. And this is why the ancient civilizations like the Maya believed that we were living in the 5th age of the sun, which is now that there had been 4 previous magnetic shifts which had caused catastrophe on Earth 4 times previously in this 18,000-year cycle.
Maurice, I want to ask you right there about some of the things, basically where we are now with all of this then, because obviously, as you've been detailing, the sun is a driving force behind the cycle, I guess, of catastrophe that we've seen on this planet in the past, of course. And you're talking about many different types of cycles here, 187 years, 18,000 years, and so forth. But where are we now in terms of 2012, the ending of the Mayan calendar? It has been predicted previously that we're supposed to have kind of a peaking of the 11-year cycle of the sun now around 2012, but recently now they've been kind of pushing that forward. Something else seems to be going on. A recent article that we linked up on Redis Creations read, for years scientists have been predicting the sun would by around 2012 move into solar maximum, a period of intense flares or sunspot activity, but lately a curious calm has suggested quite the opposite. According to 3 studies released in the United States, experts believe the familiar sunspot cycle may be shutting down and heading towards a pattern of inactivity unseen since the 17th century. Now, is this correct? Is it part of a larger cycle, or is something else going on right now, Maurice?
It's again, it's described in Future Science, and it's very, very simple. What happens is that the vertical dipole magnetic field of the sun from north to south changes direction about every 11.5 years. Now, the actual duration changes over the period of history in question. It depends when you make your observations, and it depends which cycles you take into consideration, because you've got these 2 cycles mixing together, and that's why they're slightly different. It ranges from about 11 years to about 11.5 years. But what happens is, every now and again, like from 1645 to 1715, during the Maunder minimum, there were no sunspots at all. Now, of course, some people say, well, hang on a minute. If the magnetic field of Mercury it drives the equatorial region of the sun, then what happened during 1645 to 1715? Well, it's pretty obvious. From 1645 to 1715, the magnetic field of Mercury disappeared, and so it stopped winding up the sunspot cycle. It's very simple. So now we have to look for a mechanism of, well, how can the magnetic field of Mercury disappear? And again, when we look for it, it's very simple. And it happens not just in 1645 to 1715, it actually happens every 11 years, 11.5 years, when the sun's vertical magnetic field changes direction. It flips from north to south to north. Now, when that happens, we get a pulse of energy induced into Mercury. A pulse of magnetic energy is induced into Mercury, and that energy heats Mercury up. Now, the magnetic field of Mercury is very similar it's driven, it's generated the same way as it is on Earth. In other words, because the center of the planet is solid, and just outside of the center, the atom, is molten, it's red hot magma which moves, it circulates inside the planet because of the spinning rotation, the movement of the planet. Because we have molten iron moving against a solid iron, we get electrical eddy currents, just like when an iron railway wheel rubs against an iron track, we get voltages that cause sparks. The voltages cause the air to break down between the wheel and the track, and we get what we call a convection current, which is electricity going through the air, a common spark. Now, the same thing is happening on Mercury. Mercury has a solid core, and it also has a molten interior just on the other side of the core. The molten core circulates against the solid core in the middle. Now, what that means is Mercury has a magnetic field which from north to south, just like we do on the Earth. Then what happens is, when we get this pulse of energy from the sun every 11.5 years, Mercury heats up. Now, when Mercury heats up, what happens is, the reason the core, just let me go back a minute, the reason the core of the Earth is solid and the reason the core of Mercury is solid is not because the middle is cooler. The middle of the Earth is hotter than the bit further out, which is molten. So we say, why doesn't the middle of the planet go molten liquid? And the reason for that is because it's inside the middle of the planet, so it's under more pressure. It's deeper down in the planet. And temperature, if you want something to boil, then the more pressure you put on it, the higher the temperature you need to make it boil. If you take a kettle of water up to Mount Everest, it'll boil at a lower temperature than it will at sea level.
Right.
And the same thing happens with liquefaction of the inner core of the Earth. The deeper you get into the Earth, the more difficult it is to make it boil. It'll get hot, but it won't boil. So although the center temperature is red hot and hotter than the temperature slightly away from the center, it means that the pressure has more effect. And what that means is that we get circulating molten rock away from the center, but solid rock in the middle. Now, just going back to Mercury, when the sun's magnetic field changes direction every 11 years, we get a pulse of magnetic energy flowing across Mercury. Mercury gets hotter, but Mercury is only a quarter of the size of the Earth. So the pressure in the middle of Mercury is a lot less than it is on the Earth. So the core of Mercury is prone to liquefaction. As soon as you increase the temperature, it melts instantly. And as soon as that core melts, the magnetic field disappears, because now you've got a molten core and a molten circulating magma, so there's no differential rubbing of rock inside the planet Mercury. What happens then, after 11.5 years, when the sunspot cycle flips, it's about 2 years later, when the sunspot, when Mercury cools, it radiates the heat from the planet, this excess heat, and the Mercury regains its magnetic field as the core solidifies again, and Mercury starts to drag the sunspot cycle again around. So what we expect is, every 11.5 years, if you look at the sunspot cycle, the actual sunspots disappear for a couple of years. As the magnetic field flips, as Mercury gets hot, as Mercury loses its magnetic field, the sunspot cycle stops being driven by the magnetic field of Mercury, and the sunspots disappear. And this is what's happened over the last few years. We're in the middle of a 22-year sunspot cycle. It's flipped after 11 years, but it's not started again. And the reason it hasn't started again is because Mercury magnetic field has not come back to life again. The reason it's not come back to life is because it's too hot. The reason it's too hot is because the energy induced into the planet on the last reversal must have been unusually high. So,
interesting. Does that mean that it will build up and we might even get a stronger sunspot cycle now when it begins again? Yeah,
it will definitely build up, because nothing can happen for 11.5 years, because that's a solar cycle that flips every 11.5 years, as far as we know. It's indigenous to the sun. So nothing's going to happen now on the sun for 9 or 10 years, because it's just happened. So eventually, Mercury will cool down. Its magnetic field, I mean, what I'm saying, will be substantiated in the months and years to come, because we now have a spaceship orbiting Mercury called Messenger, and it's measuring the magnetic field. So all of this information I'm giving you will be substantiated over the coming years. There's no question about it.
Yeah, very, very interesting. So where are we now? Where does this place us then in terms of the sun and the connection with the ending of the Mayan calendar, 2012, etc.? Is the sun going to pick up? Is it not going to? Are we in for a magnetic reversal of the Earth's magnetic field, Maurice? What do you think?
No, absolutely not. In fact, this whole 2012 bit goes back to 1995. And at that time, I wrote a book. It was called The Mayan Prophecies. And I took it to a publisher in the UK called Element Books. And I said, I've told them everything I told you. And they said, well, what we need to do is sensationalize it and pretend the world's going to end. That way we'll sell more books. And I said, well, I can't go along with that because I found no evidence that the world does end. And they said, well, can't we say the Mayan calendar ends in 2012? I said, well, no, because the Mayan calendar does not end in 2012. The Mayan calendar has 8 different cycles. It's made up of 8 cycles. 4 of the cycles come back to 0 in 2012, but the other 4 don't. There is no end of the Mayan calendar in 2012. So that's the first misconception. The second misconception is, what I was saying is that the sun's magnetic field was the cause of the decline of the Maya in AD 750. And that same cause will not happen again for another 3,000 years. So that will not happen, and in our lifetime, certainly, and it will not happen until the year, it's about 4,600 or thereabouts. There is no magnetic reversals from the sun on the way that will affect the Earth. It won't make the Earth tilt on its axis. It won't unduly affect fertility on Earth until the year 4,000 and odd. It's all a scam. And some people have blamed me. It had nothing whatsoever to do with me. I've disowned myself from the book. Excuse me. But what did happen is, in the book, they said, but you must be able to say something about 2012. And I said, well, look, in 2012, it will be 1/5 of a sunspot cycle. So if we multiply this period by 5, we come out with 25,800 years. And that's the cycle of precession. So maybe they were trying to tell us that the Earth might suffer from a wobble. In other words, by using the precession cycle as a marker, 1/5 of a sunspot cycle multiplied by 5 is the cycle of precession. Maybe they were trying to tell us simply that the Earth tilts off its axis due to solar activity. In other words, when the solar magnetic field twists, not only does it twist Venus off, but sometimes it twists the Earth off its axis. And I said, apart from that, I can't say anything about 2012 because there's nothing to find. I've researched it, there's nothing there. And what happened was, within 2 years, 2 or 3 other researchers had seized upon this part about the precession cycle. They'd all written books about how the precession cycle was going to cause the end of the world in 2012 and how the Mayan calendar ends in 2012, and it doesn't. And if anybody would like the facts on 2012, they can look at my website, and there's a paper on there I put on there 2 or 3 years ago called Dispelling the Myths of 2012. And it looks at every argument put forward in all of these other books, and it also shows why the Mayan calendar doesn't end at that time, and why it's all, quite frankly, a sham.
All right, that's very good. So no looming disasters or doomsday here in the next few years then, Maurice, huh?
Well, nothing that I can't see at this time anything that will tilt the planet off its axis due to solar magnetic reversals. But what I've shown in the book is that global warming and global cooling on Earth is affected by the sun's shifting magnetic field. And even though the sun doesn't tilt on its axis sometimes, most times, the magnet inside the Earth that's rotating will be influenced like a compass needle. So when the sun's magnetic field starts to move and move about from northeast to southeast, the magma inside the Earth will start to tilt like a moving disk, and that will rub against solid rock, create heat inside the planet. That'll cause the blowing of volcanoes. That'll cause lots of ash to get blown up into the atmosphere, and that might cause the onset of an ice age. So the simple movement of the sun's magnetic field, rather than a magnetic flip, the simple gradual movement over thousands of years could tip us into an ice age rather than global warming.
That's right. It's that's what I feel as well. Actually, we're talking with other researchers on this as well. It seems that it's in the total opposite, as opposed to what the mainstream out there is trying to popularize in terms of global warming. But Maurice, we have so much more to discuss and talk about, obviously, and I want to take a little break here and then continue in the next segment here for our members, of course. But we want to mention your book title again: Future Science, Forbidden Science of the 21st Century. It's an excellent book. I've been enjoying it so much, Maurice, and again, the illustrations is obviously key to go along with a lot of the things that has to do with the explanation in terms of how gravity works, electricity, magnetism, etc. It's wonderful, and I guess the best way for people to go about this is to go to your website to pick up a copy of the book. Is that correct, Maurice?
It is, yes. In fact, it's the preferred way to order it. Just click onto my website, and you can click order a copy of the book through PayPal, and we dispatch it from here, and it'll be signed by the author. So it'll be a treasure to keep for the future in chemistry, and it lies in physics. And one of the problems of modern science is that these disciplines are very separated and individual. The physicist doesn't know what the engineer is doing. The engineer doesn't know what the chemist is doing. The chemist doesn't know what the other two are doing. And it's very difficult for a specific researcher who's bogged down in his own discipline to appreciate how all of the disciplines relate to each other.
Yeah.
And being an independent researcher, I've taught myself from looking at ancient civilizations in the beginning many years ago, and to looking at spiritual inquiries as to, for example, what God is and what heaven is and what hell is, and the sunspot cycle and things like that, which I found fascinating. And I had to bring all of these things together to get a complete picture of life, the universe, why we're here, why we live, why we die, why this has to be. And one side, that was all my groundwork. I did my apprenticeship, if you like, in things like that. So when I got, I actually sat down one day and I said to my wife, it was winter in Ireland where I live, the dark nights had come along, and it was Christmas, just after Christmas time, 2007, and I said, I think the next project will be gravity. And I sat down on January the 1st, and I started to look at gravity. And 42 days later, it was on Valentine's Day, I realized how gravity had to work.
I want to try to answer some of these very difficult questions, Maurice.
It's absolutely essential. If, for example, to use an analogy, you're driving in a car and the car swerves off the road and finishes up in a ditch, it's no good trying to push the car out of the ditch. You have to pull it out backwards and figure out how it got into the ditch in the first place. Now, my view is, if you give a physicist a shovel, he'll dig a hole. And they've been digging a hole for 80 years. And now they can only communicate with each other inside the hole. They can't communicate with people outside the hole. Their ideas are fixed. They can't see anything because they're in the dark. And it takes somebody from the outside, from the periphery, with a completely fresh mind, who has nothing to lose by arguing with them. You see, these people, they can't argue with themselves because they get thrown out of the institutes and things like that. I'm not a member of the Institute of Physics, so they can't hurt me. They can't throw me out. I'm an engineer. I'm a member of the UK Institute of Engineering and Technology. It's not within their remit to look at gravity or the fundamentals of electricity. They acknowledge that that falls within the Institute of Physics. So it's got to come from somebody on the outside who's got nothing to fear from being thrown out, if you like, or attacked by these people, and who can see things with a fresh eye. One of the problems has been, when I started to look at this, was I had to learn as I was going along, because the answer lies both in engineering. It lies simple, it's complex at the same time, and yet without the graphics and the illustrations, I think it's like having a game of chess, thinking 12 steps ahead. And it's very difficult to explain unless you can illustrate it. And the new book, Future Science, has got more than 140 illustrations, most of them full page in color. And it's for the general reader with no previous knowledge of science. And it explains, if you like, a grand unified field theory. It explains how electricity and magnetism work together to produce a force of gravity, which allows us to understand why objects fall to the ground when we drop them. I mean, it's hard to believe in this so-called modern age of 2011 that modern man cannot explain why objects fall to the ground when we drop them. I mean, it's quite bizarre. We are, in fact, very primitive beings. And once we get our head around the fact that we're primitive, that's when we start to make progress.
Absolutely. I mean, you're an engineer and a scientist, Maurice, but in one way, as far as I know, you're not associated with any university per se. You don't, you know, come from, you're not in the world of academia. You're kind of standing on the outside of that, of course, as well. But at the same time, a lot of the people who came with new ideas were from that world as well. People who never finished school, the people who are you know, fundamentally capable of thinking outside of the box, so to speak. This seems to be a kind of a necessity, if you will, when you.
Absolutely, Henrik. Questions that I've been asking all my life, and I was very dissatisfied with how orthodox science is addressing these questions. We seem to be getting nowhere over the past 80 years, since Rutherford worked on the atom and since James Chadwick worked on the atom in the 1930s. And I began to consider, like many others have before me, that the orthodox science must be looking at things in the wrong way. So I decided to answer the questions in orthodox physics rather than trying to answer the big one of gravity. I started to address all of the other smaller questions, which were just as important. For example, why doesn't the atom spring apart, given that it's filled with positive charges in the nucleus? Why don't the nuclei of atoms just spring apart? Another one of the basic fundamental questions of physics is why don't the orbiting negative electrons get sucked into the positive nucleus? Nobody seems to know. And yet we're trying to figure out how gravity works when we can't understand how the atom works. Is it any surprise that we're not making any progress? Another of the fundamental questions is why are the orbital shells of atoms offset as they are? Nobody knows. How does gravity work? We'll address that shortly. How does permanent magnetism work? They don't know. If you ask a physicist how permanent magnets work, they say it must be magic. That's why they called it a magnet. How does electricity work? At atomic level, nobody knows. Nobody knows why, when an electric current flows through a wire, a magnetic field is established around the wire. And we can look at the field of astrophysics. Why do stars cluster as they do? Orthodox physics talks about dark matter, but it doesn't make sense. Why are the galaxies spiral-shaped? Again, nobody knows. It shouldn't be that way. What drives the sunspot cycle? Again, nobody knows what causes a sunspot cycle. What causes global warming and global cooling? Now, if we are to figure out the fundamentals like gravity and electricity and magnetism, we have to start with the atom and the fundamentals of magnetism and electricity. And that's what I've done in the book. I started at the beginning. I went back to where we were on firm ground with Rutherford and Chadwick in the 1930s. I looked at the atom. I looked at the changes they made in our understanding of the atom. And from there, it was all downhill. And it was very simple to figure out how gravity worked once I'd figured out what made the atom stable, for example. And it took me 6 weeks to figure out how gravity worked. That was in 2007. And it's taken me 3 years to find a way of explaining it. It's